Today you're going to perform a lab in groups of 4 where you're going to try to verify the law of conservation of momentum in 2 dimensions. As I marked your labs, your one-dimensional collision labs last night, I found that probably 75% of the groups found that momentum in one dimension was conserved, which is pretty good results for us given the relative crudeness of the experiment. We'll see what happens today when we try to verify the law of conservation of momentum in 2 dimensions. So essentially, here's what's going to happen. You're going to take 2 baseballs, and you're going to collide those 2 baseballs in 2 dimensions. You're going to take one like this, and you're going to roll them at each other. Now, if they were rolled at each other at exactly 90 degrees, then that would be great, because that makes life a little bit easier, right, when we're not dealing with funny angles. But that's pretty difficult to do, so don't worry about it if it's not exactly 90 degrees, okay? Don't worry about it. Just fire them at each other like this. You want them to collide right here. They will, after the collision, go off as 2 separate objects. Object number 1 probably over here, and maybe object number 2 over here. That's it. Okay, that's effectively it. There's our collision. Now, if you happen to find that object number 1 pretty much stops right afterwards because you didn't collide them very well, let's do another trial. Okay, if you happen to find that object number 1 is going way faster than object number 2, and it pretty much just pushes number 2, completely obliterates it out of the way, well, then just do another trial. You want a trial that looks something like this, right? More or less like this, where both objects are moving perpendicular to each other, not necessarily, but afterwards, they also both have some significant motion as well, all right? Okay, that's effectively it, but how do we actually collect data and analyze data? Well, finding the masses is pretty easy, right? Finding the masses is as simple as using a triple beam balance scale. I know you're thinking probably that they're 2 baseballs, so they should be the same mass. Not necessarily. If you play baseball or know something about baseball, you know that even in Major League Baseball, there's actually a little bit of range that's acceptable for regulation baseballs. Well, we're not using Major League baseballs. We're using cheap Walmart baseballs, so there's probably even more of a range. It won't be very much, but it could be a difference of a couple grams easily. You need to measure the mass of both of the baseballs, and record them. Okay, that's easy, right? Now, how do we record the actual motion of ball number 1 and ball number 2 immediately before and after the collision? This is where you're going to do something that you haven't done before. This is where you're going to take your phone. One person in the group is going to take your phone and video it. Now, when you're videoing it, I don't want you to stand there with your phone, like as the balls are moving on the floor colliding, stand there with your phone like this. What's wrong with that? What's wrong with standing like this and videoing it with your phone? There's a few things wrong with it. What's one of them, Laura? We're not going to see the proper angles exactly because we have what's called parallax error. It's like when you're sitting in the passenger seat of the car and you look at the speedometer and you think the driver's going a certain speed, but they're not really going that speed because you're looking at it from an angle. Okay, it's a parallax error. We don't want that, right? So we want it to be directly above, as much as possible, directly above, right? What's the other issue with standing there like this holding it? I'm holding it. What's the problem with holding it? Okay, shaking, right? Now you're not, that's an exaggeration obviously, but any kind of movement of the phone is going to distort your measurement of the movement of the baseballs. So you want to avoid doing like this at an angle. You want to be directly above it, at least as much as possible, and you want to have it braced somehow. So maybe you brace it off the edge of a desk or whatever the case may be like this. Does that make sense? And then just hold it with a finger or whatever. Got it? All right. You will, you guys know how to use your phone to video it, okay? You will need to make sure that when you video it, you have a meter stick in the video. Okay, the reason you have to have a meter stick in the video is because you need to tell the software that you're going to use to analyze this what a meter is. The software program doesn't understand what a meter is unless you tell it what a meter is. So it's going to be able to measure position and time of these 2 baseballs if it knows what a meter is, In other words, if you've told it what a meter is. So let's put the meter stick in there somewhere. Doesn't really matter where it is. It doesn't have to be perfectly straight, whatever. The meter stick goes right here. That's fine. Just make sure that you don't put the meter stick anywhere where it could get in the way of the baseballs. You don't want the baseballs to hit the meter stick, because obviously then you've got a pretty significant external force and you don't have anywhere close to an isolated system there, right? So make sure it's in the frame of view of the video, but make sure that it's not going to get in the way of the baseballs. And you might have to play around with that for a little bit. That's not a big deal. Okay, if you end up having to take 2 videos or 10 videos, it doesn't really matter. Okay, as long as you get one video that's good, that shows a good collision with both significant motion of both baseballs before and after, and shows the entire meter stick. Okay? Once you've got that video, then it's a matter of analyzing it. You're going to analyze the video on a software program, one computer, one software program for each group. Once you've got the data, then what you can do is share the data with everybody in the group, and everybody can be working on the same document on a different device. So that means that everybody can be providing significant contribution to it once you've got the data, right? Once you've got the video itself analyzed. So how do you analyze the video? Keep in mind as I go through this, these instructions I've printed off for you, and they're in a little booklet over here. There's a few different instruction sets for different things in these booklets. This is towards the back of the booklet. You'll see it, okay? You'll recognize it. So everything that I'm putting up on the board here right now is printed off for you, and you're going to be able to take that in to the biology lab when you're doing this, okay? So you don't have to memorize any of this stuff. First thing you got to do is get your video to the computer. Now, it's going to be on your phone, so you're going to transfer it to the computer. Now, there's a couple ways of doing that. You can upload it to a Google Drive and then download it to your computer. That sometimes takes a lot of time because our wireless network doesn't always work very well. My suggestion would be to connect your phone to the computer. Now, I've got some cords. Okay, I've got iPhone cords and I've got cords that'll work with Androids, the little micro USB. There's not enough. I think I've got 3 iPhone cords in there, and I think I've got 4 or 5 cords that'll work with Android. You might have to share, okay, between groups, depending upon what devices we're using. But the easiest way is to transfer it that way. On iPhone, and maybe on Android as well, I'm not sure because I don't use an Android phone myself. When you plug it in, it's going to ask you if basically you want to give this computer permission to receive the videos and pictures on your phone. And you're just going to say yes. And then you're going to treat it just like a USB drive. And literally drag the video from the folder on your phone to the desktop of your computer. So however you get it there, whether it's by Google Drive or whether it's by connecting it, you want the video on the desktop of your computer. Open up the software program called Tracker. There's an icon on the desktop. The desktops are pretty bare, so you won't have any trouble finding it. Open up the software program called Tracker, and then open up the video that you want to analyze. Okay, you're going to have to find the right folder, but it's easy if it's on your desktop, right? It's easy to find it. Just keep going up, 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 up. Right? Keep going up, 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 up a directory to the desktop, and you'll find that video there. Open it, and when you open it, you're going to see your video there. Right? What's missing from my video? Oh, no, I see it, actually. I didn't see it at first, actually. It is there. The meter stick is in there, right? Now, what's the problem with the way that I have this set up? I didn't really, when I took this picture, I didn't really perform this experiment. Okay, so I wasn't paying enough attention to the details of it, right? What would be the problem that this actually was a video that I was using to collect data? Yep. Yeah, I would hit the meter stick. Here's the meter stick. Here's ball number 1, ball number 2, or whatever, whichever one is which. When I collide those together, they're going to hit the meter stick. I don't want to do that, right? I want to have the meter stick somewhere where the balls are not going to hit it. Now, notice as well that you can't see the entire meter stick there. That's okay, actually. If you can only see part of the meter stick, you can end up defining 50 centimeters as opposed to 100 centimeters, or 30 centimeters as opposed to 100. The problem with that is it's difficult to make the numbers out on the meter stick. It's easier to see the start and end of the meter stick, so you can define exactly a meter. If you have to define 50 centimeters because the meter stick isn't all in the frame of view of the video, then you're going to have to figure out some way of determining what that 50 centimeters is on the meter stick. All right? Okay, so the first thing you do after you get your video opened is click on this axis button. That's going to add a frame of reference. So it's basically going to define where we're measuring the position from. It doesn't really matter where that frame of reference is. I usually drag it towards the bottom left-hand corner of the screen, okay, but it's not really a huge deal because everything is going to be measured from that frame of reference, wherever that frame of reference is. Okay, the next thing you're going to do is add what we call our calibration stick. Okay, so click on tracks up here at the top, click on new, click on calibration tools, then click on calibration stick. This, by the way, is my frame of reference that I put in the bottom left-hand corner. The calibration stick is going to be what calibrates a meter with the meter stick. You can see that since I didn't have my entire meter stick there, I just defined part of the meter stick, and I can't even see what that says. 30 centimeters. So I defined 30 centimeters on my meter stick, and it'll give you the opportunity to type in the value that you want. Keep in mind that the units it uses is centimeters as opposed to meters, which is not a huge deal. Okay, then you have to define your points. Define point number 1 and point number 2. So what you got to do is create a point mass. Create, right up here, a point mass for both objects, for object number 1 and object number 2, since you've got two objects colliding here. And then you want to scroll along the bottom to the point where you want to start analyzing, right? Your hands are going to be in the video for a little while, right? You're pushing these baseballs along for a little while, right? So that means that there's external forces acting there. We don't want to analyze that when there's the external force of your hand acting. So start analyzing after the ball has left your hand. See my hand right there? See the ball right there? It's left the hand. You can start analyzing there. So scroll along the bottom until you reach that point, and then start analyzing. Does that make sense? Now, keep in mind, you're going to analyze the motion of one of them at a time, object number 1 or object number 2. They don't have to start at exactly the same place. So you can see that this one, my hand is kind of still touching it. This one, it's left my hand. I could start analyzing this one now. I might want to go forward a few frames before I start analyzing the other one. Does that make sense? It's okay if you start analyzing the baseballs in different places. So how do you start analyzing it? Well, click on mass 1 or mass 2, or mass A or mass B, I guess they call them. Pick one, like pick mass A or pick mass B. Probably A is going to go first, right? And then you're going to trace frame by frame the motion of this baseball. You're going to hold the shift key, and then you're going to use your mouse to click. So shift, click where the ball is. I would go shift and click that spot. And then it's going to automatically go forward 1 frame. Then you're going to go shift, click where the ball is now. And it's going to automatically go forward 1 frame. And then you're going to go shift, click forward 1 frame. And so on and so on and so on until you're finished collecting your data, till it's after the collision has taken place. So shift click is going to mark your spot. What you're going to end up seeing is a bunch of X's tracing the motion of it. Does that make sense? Now that's for one object. You're going to end up doing the same thing for the other object when you're done there. So do the first one. Okay, great. Then go back and click mass B up here and do the second one. Do exactly the same thing. All right? What's it going to look like? After that, well, you can see I got these spots here, okay, that I clicked on. You're going to see some data in the bottom right-hand corner. Data for one object at a time, either mass A or mass B. Okay, you can click on mass A to see the data for mass A, or you can click on mass B to see the data for mass B. You're going to see time in the first column. I know it's hard to read this right now, but time in the first column, it says X and Y. So this would be the position horizontal. This would be the position vertical. Make sense? You're going to, for each mass, mass A and mass B, you're going to select all of that data by clicking on a piece of data, going Control A, and then that's going to, so Control A is going to select it all, Control C is going to copy, and then you're going to go to Google Sheets and click Control V. That's going to paste all of that data into Google Sheets. Okay? Then you're going to do the same thing for mass B. Make sense? So now all your data is in Google Sheets. Now you can share it with everybody in your group, and everybody can be working on a separate device and starting to do the analysis. Okay, and that's important that everybody has access to that, because there's going to end up being a number of graphs that you're going to have to plot in order to write this up. Okay, we need 8 different velocities. 8 velocities. Okay, we need the initial velocity, x component, mass 1, the initial velocity, x component, mass 2, the initial velocity, y component, mass 1, the initial velocity, y component, mass 2, and so on. So there's 8 different velocities that you're going to have to find, and you're going to find those all by graphs. But before you do that, you're going to have to plot, we'll call them preparatory graphs, so that you know where to separate your data. If I'm going to take my data that I got from here, that's now on Google Sheet for mass A, and I'm going to plot a graph for the x component. We'll say position x versus time for mass A. And the graph might look like this. That tells us that we have a constant velocity before the collision, x component, a constant velocity, what's this? After the collision, x component, right? What you're going to need to do is separate this into 2 graphs. Does that make sense? So position x versus time for mass A, you're going to have to turn it into this for initial, and this for final. And then from this, you're going to get the velocity. In other words, the slope of the graph, which Google Sheets will give you. So for mass A, x position versus time, you're going to get 2 velocities. You're going to get the initial x component for mass A, the final x component mass A. And then you're going to do the same thing for position y versus time, mass A. And then you're going to do the same thing for mass B, position x versus time and position y versus time. Okay? It's a lot of work. And that ends up being 12 graphs. Okay, 4 of these ones, 4 of these preparatory graphs, and then 8 of these ones that actually give you the velocities. But the good news is you're sharing the workload because you got 4 people in your group. And the good news is once you've got that data, you're just going to fill in a template that I've already created for you. Okay, the template is organized in exactly the way I want you to present it. It doesn't require a procedure. It doesn't require anything beyond what you see in the template that's already in Google Classroom. Your data, your analysis, which tells you what analysis to do, and then finally, percent difference calculation, which is going to lead to a conclusion of was momentum conserved. All right? So, you will, when you go onto Google Classroom, everybody's going to see this assignment because one person's going to submit it. I'm going to see a lot of not handed in. That's okay. At the top of that template, it has a place for everybody in the group. It has a place for their name. You need to type in the first name and last name of everybody in the group, and then one person has to submit it so that everybody gets credit for it, right? Just make sure you share the document with everybody in your group so that everybody can work on it. Okay? Document and the spreadsheets. Is that kind of clear? I know we went through a lot there, including the software program and so on, but the software program, the instructions are there, like literally in black and white and color in front of you so that you can follow that. And if you have any questions, you can let me know as you go.